So our objective is I can identify key features of an exponential function. We're going to do that today. Now, we should be graphing this. So let's do that real quick. Let me pull up my calculator. Now, I always say to make a new graph, right? A new graph. So new document, don't save, number 2 for graph. Now, I know there's not like, this is not a multiplication dot, but it's supposed to be, so it's supposed to be 3 times 2 to the x, okay? So 3 times 2, y'all know caret over here, this button right here is caret x, and then minus 2 needs to be, we don't have headphones in. Can we? We need to subtract 2 after it. So you have to go to the right and then put minus 2, okay? Now, once you hit enter, it graphs it for you, cool? But I wanted you to do what? It says to fill out a table. So hit menu 7-1, we learned that yesterday, menu 7-1, and give me this table. Now, typically they're gonna want some negative numbers, so you could do that. Let me do this. What's going on? There we go. All right, so now if you just put the numbers at the very beginning that you saw first, that's fine, okay? It's still a table, but I'm gonna do -2, -1.25, -1, -0.5, 0.1, 1.4. All right, so you should be able to get a table. Everyone wrote down a table, and you wrote down the objective for today. Okay. Like every Friday, we're going to pick these up. Should be an easy 100. Now, if you missed a day, put absent on that day. Okay. Make sure your actual name is on it somewhere. Okay. Otherwise, it ends up in that red folder, and usually no one gets it. Okay. The no name folder. So you can pass those up to the front. I'm gonna pass out your notes that we're doing today, and then we're gonna do that together. Okay. Here we go. So we're doing some formal notes on exponentials. Okay. We talked about growth and decay, we graphed, we got a table from the graph, but from an equation, you need to know some things, and that's what we're doing right now. So, here we go. If I can zoom in. Okay, an exponential function, if it will zoom in, that would be cool. Okay, not too much. Got that lag going here. One of those days. What's the deal here? All right, so exponential functions. The key features. Exponential function is a function where the exponent is a variable. Please write this down. Okay. All right. Is everyone writing this down? A exponential function. Like when we graphed this yesterday and today, you noticed the little x in the exponent. That's what makes it exponential, right? So a variable x will be in the exponent, okay? Now, here's your exponential equation. Y equals a times b to the power of x. If you're on a phone, you're wrong. So a times b to the power of x, right? Now, what is a? What is b? Okay. Now, a is our initial value. It's what you start at, or it's the y-intercept, okay? So let's write that down. It's the initial value, or in these basic cases, it's the y-intercept. Everyone write that down? Everyone write that down? And then b is the rate of growth or decay. I'll have to move here in a minute, so let's write it down. So again, A is where you start, B is how much it's changing, And if you remember a couple days ago, it's how much we're multiplying by each time, right? It's not adding each time, but it's multiplying each time. Now, who thinks they can pronounce this word? It's actually right. So the P is silent, like in pterodactyl. Do you know pterodactyl has a P in it? It's actually the first letter. Asymptote. Now, here's the deal. Asymptote is a line you can't cross, right? Now, all y'all, all day long in this class, crossing the line all the time. But in math, there is a line you cannot cross. It's an asymptote, okay? Now, it is a blank line that a graph never intersects. So, a line that a graph never intersects, asymptotes are drawn as dashed lines. They're horizontal dashed lines. It'll look like this. We're going to do examples together. This is just the notes part. Oh, you say you remember? Oh, you already know. Yes. This is a throwback to the end of Algebra 1. So now, exponential growth. When b, your growth factor, is greater than 1, the graph will be a growth function. When b is greater than 1, okay, so anything greater than 1, it could be 1.001, that's still technically exponential growth. But if b is not greater than 1, but not negative, so basically between 0 and 1, if it's some sort of fraction or decimal between 0 and 1, let's write it like this: 0 less than b less than 1. If b is between 0 and 1, then it's going to be a decay function. All right, we're about to flip it over, so make sure you get this stuff down. Something's happening in my birth month. All right, so, all right. All right. I'll be. No. No, but it might be. But it's not. But it might be. All right.
You're gonna give me a headache. I don't want to hear it.
Wait, no, is today your birthday?
No.
You go.
Why?
No, it's making it sound like
This is not funny. All right, so let's do this. I'm not. I'm just very tired. All right, here we go. Now this is like our warm up. We want to graph this. Listen, we want to graph this and get a table. So let's do that. I'm going to put it off to the side here. Pull up the calculator again. Now, new document. Don't save. Graph it. Okay, now we're doing 2 times. You need that thing, right? Okay, 2 times 3 to the x. 2 parentheses 3, and then caret x, right? Sorry, caret x, not caret 3. Caret x. Okay, now once you graph, or once you type it in, you hit graph, and you'll get your graph. What we need to do is get a table. What do we press for table again? Menu 7.1, it'll give us a split screen of our table, menu 7.1. Now, before you write down this table exactly the way it is, do you see how the graph paper they gave us goes up to 19? So obviously 54, 162, those are too big. So what I want you to do on your table is scroll up a little bit. You'll see, actually too far, right there is perfect, okay? It can't go above 19, so we're gonna use these 5 numbers right here, okay? So let's fill this out. X, y, -2, -1, 0, 1, 2. And we're going to round these little weird decimals, 0.22, 0.66, and then 2, 6, 18. See if you can plot those and graph it.
Graph it like this, and just draw the line.
Right. So if you plot these 5 points, I'll help you. Let's plot these 5 points. Ready? Ready? So -2, 0.22. So that means at -2, it's barely going to be above it. Put a little point right there above -2. Now, -1, 0.66 is a little bit above halfway, right? 0.5 is halfway, 0.6 is a little bit above that. So -1, 0.6 is right around there, kind of. Doesn't have to be perfect, just close. Now, 0.2 is on the y-axis. 0.2 is right there. 1,6 is up here, and then 218 is way up here. Okay. Cool. So it's going to go like this. Oh my gosh. You got to have the right points. Do you have these right points on there? Okay, well, you got to graph the right points. It's got to go through 218, 16, 02. All right, so mine is shaky and ugly, but it's something. So can you draw yourself a little exponential growth function right there? And we already talked about what was that weird A word that line you can't cross? Asymptote. So do you see how it's getting closer and closer to 0? Look at my table. I'm going to keep going down. Do you see how it keeps getting closer and closer to 0? 0.0009 is pretty close to 0. But let me tell you, it never, ever gets there. Okay, it's just getting smaller and smaller and smaller and smaller. So the asymptote, you can go ahead and draw it, is on the axis with a dashed line. Might be hard to see because it'll be covered up by the other line, but so I did it in blue on the front, but this little dashed line is the line that I will not cross. But it will get closer, comfortably close. Okay. Now, that is exponential what? Growth. What's the b value here? 3. 3 is greater than 1? It is. Then it's exponential growth, right? Okay. I appreciate it so much. Now, let's do the next one. What do you notice about the b value on number 2? The fraction is it less than 1?
Yes.
A half is less than 1, so it's going to be exponential decay, right? We can tell already, but let's go ahead and graph it. Everybody ready? Some people ain't ready. Let's do this, all right? On, new document, don't save it, add a graph, okay? So I'm going to hit 1 parentheses. Do y'all know how to make a fraction, like a literal fraction bar fraction? Yes, 1, control divide, 2. Makes a fraction with a fraction bar, right? And then we need to make sure outside the parentheses we put a caret x. Everyone's, oh my gosh. How do I get back to my functions? That's so annoying. Is it? Okay, let me do that all over again. That's dumb. Oh my gosh. Okay, third time's the charm, hopefully. 1 parentheses 1 divided by 2 parentheses caret x. Enter. Okay, you can see it's exponential decay. We're going to press menu 7-1. And let's go ahead and put down these numbers. Again, the graph paper they give us goes up to 19, so let's see how far we can go with this. Okay, so the farthest we're going to go back is -4. Okay, oh my goodness. It's wigging out. All right, so check it out. Let's use these numbers. Everyone, let's fill in this table. Go ahead and put x, y. -4, -3, -2, -1, 0. 16, 8, 4, 2, 1. Okay, so again, you can graph it, you can get a table, you can start plotting points. Let's plot these points, all right? So again, our points are -4, 16. They're all over here on the table. So -4, 16. Then we have -3, 8. -2, 4. -1, 2. And then 0, 1. Can you plot those points, please, and then graph it? Do your best exponential graph that goes through these, but it doesn't cross the axis. It just keeps getting closer and closer forever, okay? So here we go. Let's graph this. Oops. All right. Now, exponential decay down to the right. Cool? All right, write that down, and then we're going to do the right part of the notes, and then we'll be done. Yeah, we'll see. All right, now, last part of the notes, we have a exponential growth function. We're going to make a table real quick. I'm going to make it up here. Everyone, let's do this quickly so we can get it over with, right? We got x and y. All right, we got -2. I'm going to say that's about point 0.1 or something. And then at -1, we got about 0.3 or something. At 0, we have 1. At 1, we have 3. And at 2, we have 9. I'm able to plot these points, put them in a table. Or not plot them, but I'm able to identify the points, put them in a table. Now, what's the pattern? I'll write these down. You should write it down that way you know. Right. But what's happening each time? It's not adding the same number because it's exponential. It's multiplying. What's it multiplying by each time? What do you think? To get from 1 to 3, you got to multiply by 3. To get from 3 to 9, you got to multiply by 3. Right? That makes sense? So again, you're looking for the multiplier when you're doing these tables to figure out a b value. Let me show you what I mean. When it says function, what kind of function is it? It's exponential what? Well, we're going to answer that later. What kind of, but it's exponential. And remember, our formula is y equals a times b to the x. Now, a and b are right here. What's the starting amount? When x is 0, what is y? Right here, right? 1. Intercept. Y-intercept, yes. So the y-intercept is 1. That's my a value. So I already know half the equation. The a is 1. But the b, what is the rate? We already said it, but how much is it multiplying each time? 3 times 3 times 3 times 3. That's my rate. So if a is 1 right here and b is 3 right here, could you write an equation of that function? Yes. Let's write it. Y equals what? What's a? 1. And then what's b? 3 to the power of x. Now, there's ways to do this in your calculator, like a regression with menu 41 something else, okay? But I'm just saying, if you know the multiplier and the starting y-intercept, you can already write the equation. Just saying. Now, we already said it's growth, not decay. Asymptote. Now, do you see how it's going and never touching this y-axis right here? Now, I'd be impressed. Does anyone know the formula for a horizontal line? Zero over 1 would be the slope of it. But whenever you have a horizontal line, it's always going to be y equals a number. Because the 0 slope times x eliminates the x. Okay? So y equals, and since it's going through the origin, it's y equals 0. Go ahead and write for the asymptote, y equals 0. That's the horizontal line that it cannot touch. Okay? Asymptote, yeah, so in algebra 1, they don't do that. In algebra 2, they do. And then in algebra reasoning, we barely go over it. Okay? Exactly, introduce it. So now domain. Now this was last week's notes. I know I wasn't here, but I figured you may already know. Domain is from left to right. Yeah, you see how this goes forever to the left? And this is actually going forever to the right. What do you call the forever direction in math? Look at Buzz Lightyear. Okay, so you got negative infinity, positive infinity, right? So let's write this down for my domain. Now you're gonna have to write this down. Ready? Negative, looks like a sideways 8, infinity, less than x, less than positive infinity. Okay? This is just an inequality way of saying forever to the left, forever to the right. That's in between forever. Okay? To infinity, there is no beyond. Now, range, how far down, you tell me, how far down does this go? Does it go below 0? No, you can't cross the asymptote. Does it touch 0? No, so it's only above 0. If it's only above 0, we call that only greater than 0, right? So here's how I would write it. You could put 0 is less than y, which is backwards to saying y is greater than 0. Okay? So all y values are above 0, not equal to. Don't underline. It doesn't touch. Okay? Now that's it for the notes. I'm going to pass out the assignment. We have some time today, but we're going to work on it also on Monday, right? Here we go.